Number 15. Using branch current analysis, find the magnitude and direction of the current through each resistor, and then find that, and then find voltage A. First, let's just draw the circuit. So we have a source coming this way, 4 volts going to the first resistor, and then that's node A, third resistor, and then the second resistor, and we have another source, and then that is connected to ground. So boom, boom, boom. And then we'll just label them. That'll be 4 volts, A source 1, R1, 4 ohms, R2, 2 ohms, and R3, 8 ohms, and then E source 2, which is 8 volts, 6 volts. Okay, there you go. And then we need to find the node, the voltage on A. Okay, there you go. First, identify the currents and identify KVL loops. So, when we're doing branch currents, you need to do 2 things. Identify the currents and the KVL loops. So we're going to identify the currents, and we're going to assume the current's going this way. That's I1. And then current 3 will be going this way. And then current 2 will be going this way. And that's only an assumption. And it doesn't matter if it's right or wrong. If it's right or wrong, it'll be depending on the sign we get on the last. And then our KVL loops will be this way. Our second KVL loop will be this way as well. There you go. We have identified the currents and the KVL loops. Now we're just going to do the equation for each one. So we got for equation 1, we got E source 1, and then we know that the current going this way, the resistor will be opposing that current. So the voltage drop will be going this way, and the voltage drop for this one will be this way. Voltage going this way, and then this one, since the current is going that way, voltage drop is going to go opposing that, and the same for this guy. And then this is positive, and that's negative. There you go. We have fully labeled the circuit. Now, just do the KVL loops. We got E source 1, and then minus R1 times this current, I1, and then the third one will be minus R3 times I3 is equal to 0 volts. Now we got the first one, second equation, which is going to be the second KVL loop. We're going to start this way and then go up, down. So we got positive R3, because depending on the KVL assumption, R3 times I3 plus R2 times I2 minus E source 2 equal to 0 volts. And then since we're dealing with the branch current, you have to include the KCL on node A. So we're going to do that right now. So it'll be, that's the third equation, it'll be, since I1 is entering that node, I2 is entering that node, and I3 is leaving. So we know that 1I1 plus 1I2, since these two are entering, minus 1I3, 0 amps, because of this is negative because it's leaving. Because when you do the KCL, is equal to I in is equal to I out, and the in is what current goes into the node and out what leaves it. And to get it in this form, you subtract this to the other side. Alright, back to it. We've got the 3 equations. Now we need to rearrange it to be I1, I2, and I3, and then the source at the end. Okay. So it'll be, for the first one, it'll be negative R1, I1, and then you have to include I2, since it's part of the circuit, but for the resistor of it will be 0 ohms. So it'll be either minus, plus, doesn't matter, because at the end you're going to multiply by 0. So we're going to do minus for this, 0 ohms, I I2, and then minus R3, I3, and then equals to negative E source 1, since we moved it to the other side. And then for the second one, I'll be same thing. We need to include I1 this time, so it'll be 0 ohms, I1, plus R2, I2, plus R3, I3, and then positive E source 2. Third one will be the same exact thing. It won't change the KCL. So let me just do this real quick. There you go. There you got it. We have rearranged this equation, these three, into these. We're going to be using these three. Good. And the values. Okay, now we're going to sub in the values. So for 1, we said, what's R1? It's 4 ohms. So it'll be negative 4 ohms, I1, minus 0 ohms, I2, and then R3 is 8 ohms, so it'll be 8 minus 8 ohms, I3, and then source 1 is negative 4 volts. That's for the first one. Second one would be 0 ohms, I1, plus R2, which is 2 ohms, I2, minus R3, which is 8 ohms, I3, and it's positive. And then equals E source 2, which is 6 volts. And then this is third equation, which is the KCL. 1I1 plus 1I2 minus 1I3 is equal to 0 amps. So you have to keep in mind that when you plug in the calculator, you're going to have set to the calculator, you go to mode, equations, and you got 3 values. The values you plug on A, B, C, D would be this guy. Let me just make this bigger. Would be this guy. That's A. That will be B. That will be C, and that will be D. And I do it the same thing for this one. A2, B2, C2, and then D2. And then A3 would be just the one. B3 would be just the one. C3 would be the negative one, and then D would be 0. Once you plug that into your calculator, you're going to get values for I1, I2, and I3. And there you go, my friend. You have found I1 and I2 and I3. We're going to do it at the same time. I'm going to do it and we can compare our answer. Equation, we got 3 values for I1, negative 4, 0, negative 8, negative 4, 0, 2, 8, 6, 1, 1, negative 1, 0. Okay, this is what I got. For I1, I got negative 142.857 milliamps. I2, 714.3 milliamps, and I3, 571.43 milliamps. Now, you're going to ask me, why did I get a negative number for I1? That means our assumption that I1 is going to go this way is wrong. Current I1 will be going this way. That's all what it needs. So you find I2, I3, and there you go. You have found the currents as the question asks, I1, I2, and I3. Now to find the voltage on VAB, or VA, sorry, we have to do a different analysis, which is nodal analysis. That will be in a different video. Thank you guys for watching the video. We have found the currents as the question asks. To find the voltage on VA, you only need to do voltage nodal analysis, and from there you can get it.